This video is about piecewise functions. So we're going to analyze a piecewise function, and we are also going to use a piecewise function to find values. So a piecewise function looks like a function that is broken into pieces with different parts. Does this graph represent a function? Justify your answer. So this is a function because even though there's 3 points here, only one of them is closed. So is this represent a function? Yes, because every point on the graph only has one y value for it, especially here with the closed circle only at 1 point. So is this a function? Yes, because every x value has one y value. So with a piecewise function, sometimes there are multiple points with the same x-coordinate, which is happening here. However, a graph is a function if only one of these dots is closed and the rest should be open, just like in this picture here. So when we are asking to find f of x, your answer should only be the y coordinate of the closed dot. So let's practice finding some values given a graph. So use the graph below to find the values. So f of -5. So here's -5, and at -5 there's 2 dots. There's an open and a closed. When I want you to find f of a value, I care about only the y coordinate, which in this case then is -4. When we look at f of 2, again there's an open and a closed. We want the y value of the closed dot. So in this case the closed dot is at -4 again. F of 0. So here's 0. Here's my graph, which again is at -4. So it doesn't always happen that they're all the same point, but in this case they all have the same y value. So remember how we talked about increasing and decreasing. Another thing that can happen when you are not increasing or decreasing but a flat line is that you are going to say you are constant. So a constant happens when it's a horizontal line within a piecewise function. Remember, we can also look at end behavior. So as x approaches -infinity, that's my left arrow, f of x is approaching, so this arrow is going up, which means that it's approaching infinity. As x approaches infinity, which is the right arrow, our right arrow is pointing down this time, which means f of x is approaching -infinity. How many zeros does this graph have? So remember, a zero happens when it's crossing the x-axis. So in this case, our graph is crossing the x-axis on only 1 point, which means we would have 1, 0. Keep in mind that sometimes a function can be increasing or decreasing, sometimes it can be constant. So let's decide if it's increasing or decreasing or constant over a given interval. So if I look at my graph and my interval that they are giving us is -infinity to -5. So -infinity is the left arrow to -5. I went down along that line, which means that I am decreasing. The next one is -5 to 2. So notice at -5 there's 2 dots. But we want to go from -5 to 2, which means we want to look at what this line is doing, because it's the line that exists in that interval. This line is a flat horizontal line, which means that it is constant. And our last one is 2 to infinity. So 2, we have 2 points again to start at. This time we want to start here because as we move towards infinity, this is the line that creates that movement. This line again is going down, which means that we would be decreasing. We can also find f of x without being given a graph. However, be aware you must make sure that you are plugging your x value into the correct function based on the given inequality. So the first equation we have is 5x minus 4 when x is less than -1. So think of numbers that are less than -1 that would work. So for example, -2, -3, -4, so on and so on. So all of our negative numbers that are less than -1 would work in that equation. The second equation is -2x plus 2 when x is greater than or equal to -1. Because it's greater than or equal to, this time we can use -1 and then numbers that are greater than it, 0, 1, 2, so on and so on. So let's look at what is given to us and determine which equation we can use to find the y value. So f of -5. -5 is less than -1, so we would use our first equation. So we are going to substitute this value in for x. So 5 times -5 minus 4, which would get us -25 minus 4, which is equal to -29. Our next point is -1. So -1 is not less than -1. That doesn't make sense in this inequality. -1, however, is greater than or equal to -1. So this time we're going to use our second equation and substitute for x. So -2 times -1 plus 2. -2 times -1 is 2 plus 2, which is equal to 4. The next equation gives us f of 0. So we have to figure out which inequality it works in. 0 is not less than -1. 0 is greater than or equal to -1. So we're going to use the second equation again and put 0 in for x. -2 times 0 plus 2. So -2 times 0 is 0, plus 2 gets us 2. Our last equation is f of 5. So 5 is greater than -1, so we're going to use our second equation again. -2 times 5 plus 2 gets us -10 plus 2, which is equal to -8.